Hello everyone and welcome to my channel BOBKASH University. My name is AJIT Sharma. Today we are going to learn about p-value. We have come across this term many times, and sometimes it's very mind-boggling. We do not understand what is the physical meaning of p-value. So today we are going to understand the very simple concept, in a very simple way, the understanding of p-value. Now, to understand p-value, there must be two things that you have to have a basic understanding of. Number one is a very basic understanding of hypothesis testing. We don't expect you to have a very deep understanding, just a basic meaning of what is hypothesis testing. And second, a very basic understanding of the level of significance. Now, what is level of significance? Level of significance normally in the industry is taken 5%, which means that we are okay with 5% of the sample mean coming under the rejection area, right? What is level of significance? Level of significance is the percentage that we are okay with, that the industry is okay with, for a sample mean or that is coming in the rejection area. So if we take significance value as 5%, this means we are okay with 5% of the sample means that are lying in the rejected specifications. Right. Now, hypothesis. We know hypothesis is basically two types: null hypothesis and alternate hypothesis. What is null hypothesis? Null hypothesis means everything is okay. There is no problem with the process. We are getting the desired results. There is just the random variation that is happening in the process, and random variation is fine. There is no problem with the random variation in the process. This is a null hypothesis. We are assuming everything is okay. What is alternate hypothesis? Alternate hypothesis assumes that there is some problem that has come into the process and you are going to get undesirable results, unpredicted results, or either you are getting unpredicted results or you may in future get unpredicted results. So, null hypothesis, everything is okay. There is only random variation in the process, and alternate hypothesis, everything is not okay. So these are the two things we need to have a basic understanding of before understanding p-value. So now what is p-value? P-value, P stands for probability. P-value is the probability of occurrence of a sample mean. P-value is the probability of occurrence of a sample mean that lies in the rejection portion of the normal distribution curve, under the assumption that everything is okay, right? So if I assume that null hypothesis is true in my process, that means my process has no problem. My process is running under only random variation. My process will generate only desired results. There is no problem. Everything is okay. Under this assumption, now, what is the probability that the sum of the sample means, or what is the probability that the next sample I'm going to measure, its mean will be rejected portion, right? So under the assumption that everything is okay, there is no problem with the process, there is only random variation in the process, what is the probability that the sample mean will lie in the rejected area of the normal distribution curve? Or in other words, what is the probability that the next sample I'm going to measure will be rejected? To be very simple, what is the probability that the next sample mean, let's say I take a sample of 100 units, the mean, if it gets rejected, what is the probability that this sample mean will be rejected under the assumption that everything is okay? So we are talking that everything is okay, but we are asking the probability of not okay occurrence. Let's take an example and understand this, that how do we assume that everything is okay, and we try to find out the probability of not okay occurrence. This probability of not okay occurrence is the p-value. There was a school which claimed to be one of the best schools in the town, but they got an input from the universities that a couple of students from that school were not able to clear the entrance exam of that university. So it was a negative feedback from the market, a negative feedback from the university to the school. So the school decided to look into this, whether do we need to do anything in our process, or is there something very seriously wrong in our education system, because we are not able to have 100% of the students passing the entrance exam compared to the other schools. So they decided to go for the statistical verification. The entrance exam had a cutoff marks of 60%, 60. So any person getting marks below 60% was declared as fail. So they found out the samples of the failed students from the university, and they discovered that indeed many of the students got less than 60%. That means the university was right, that some of the students failed from that school, because they found out that indeed these students got less than 60% of the marks. So the university was right. So they decided to devise the similar test and subject it to their students who were already in the school. They selected 100 students sample from the school and subjected them to the same test that the university was giving them. When the results came, they found out that the average of the results of these 100 sample students from the school also had a mean less than even 50%. So the university was claiming that your students are getting less than 60%, which is a problem for the school. And when the school took a sample of 100 people, 100 students from their school, and subjected them to the same test, they also found out, yes, the average mean, the mean of the test of these students is also less than 60%. That means university is right. Our school children are not able to pass the exam. But remember, they took only 100 samples. There were 5,000 people in that school, and we can't be checking 5,000. So they just checked this sample. But I wanted to be sure about the population, right? The school checked 100 people, which was a sample, but they wanted to know what about the population of the school. Is it also going to fail in the university exam or not? Are they going to pass the entrance exam of the university or not? So how to check the population is right or wrong? For this, they did a hypothesis testing and assumed that the students will get an average of 60% or more. What was the null hypothesis? The null hypothesis was the children will get an average result of 60% or more. That means everything is okay. If they get 60% or more, it's okay. Under this assumption, they wanted to verify what was the probability that people will get less than 60%. Right? So this example is same as what the theory which we have seen in the previous part of the video. That under the assumption that people will get 60% or more, what is the probability? In other words, what is the p-value? What is the probability that they will get less than 60%? That means in the rejected area. So they did hypothesis testing. So the results of the hypothesis testing were seen, and it was seen that the probability of occurrence of people getting less than 60%, that means in the rejection area, was 6%. So under the assumption that everything is okay, under the assumption that people will get an average of 60% or more, there was still a 6% probability that some of the people will get less than 60%. That means in the rejection area. What is this? This is p-value. P-value is under the assumption that everything is okay, what is the probability of not okay? Now the sample mean of 100 students result was less than 60%. We have seen the sample mean was less than 60%, and the probability of not okay, that means the probability of less than 60% was 6%, more than 5%. More than 5% acceptable value. That means it was normal for this process that people will get less than 60%, because 6% we consider it as a high probability. Why we consider 6% as a high probability? Because it is more than 5. So we get a high probability that under the assumption people will pass, some people will fail. So the probability is that people will fail. We got a sample mean which is fail and is also aligned with the university results. Now, that means you don't have to do anything in the process. It is the random nature of the process to produce some of the test results which are fail. So that is why you got a sample mean which was fail, less than 60%. The same way the population will behave, because you get the probability of not okay less than 60%, 6%, which is high. So there is no problem with the process. Now this is crazy. The university says your children are failing. Your sample mean of 100 students also says that the average is fail, because less than 60%. Now because the p-value is 6%, which is very high, which means it is normal. There is a high probability that people will fail under the assumption that people will pass. So there is no problem with the process. Nothing has to be done with the process, because process is running under random variation. It is under the randomness of the process that you will get some failures, because you get 6% high probability. Right? Then what is the problem? The problem is, if you need all of your children to pass in the university, you have to change the entire process. You have to revamp the entire process. But as such, the process is designed to produce some of the people who will fail. And this is the mistake we do in real life. We have a problem from the complaint. We take a sample in our industry. We say, yes, there is a problem in the sample. There is a problem in the complaint. The customer is right. But we don't see the randomness of the nature, randomness of the process, randomness of the nature of the process. If the process itself declares that, yes, I am designed in such a way that there will be some rejections, and if you try to interfere with a randomly running process, you are going to land up in an even bigger problem. So p-value validates the fact that whether the process running under random variation will produce rejection or not. If you have any questions, I will be happy to answer them. Please write them in the comments below. Thank you very much for watching my video. My name is AJIT Sharma from BOBKASH University.